In this lesson in Chapter 2, we're going to look at distances and midpoints in reference to points on a plane. And so first what we want to do is do a quick review of the Pythagorean Theorem. So in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. So the sum, which is addition, of the square of the legs. So the legs are the ones that form the right angle. So a squared plus b squared equals the square of the hypotenuse. So just so you see what this looks like, if the legs of a right triangle are 5 and 12, what's the length of the hypotenuse? Well, it gives us the legs. So we know that a leg squared 5 plus 12 squared is equal to, we'll just call the hypotenuse h squared. And so we square this. This is 25 plus 144 equals h squared. Add those together, you get 169. And you take the square root of both sides. To undo squared, you take the square root of both sides, and you get h equals 13. So the hypotenuse would equal 13. And that's one example of using the Pythagorean theorem. And what we're going to do, we're actually going to do that again as we find the distance between 2 points on a plane. So here we have 3, -2, 3, -2, and -2, 10. And we want to find the distance between those 2 points. Well, what we can do is we can actually use a vertical segment and a horizontal segment to form a right triangle. So here we have a right triangle. And so really what we're going to do to find this distance, that's really the hypotenuse of a right triangle. So we can find this length. So we're going, this is down at -2. Well, actually, we can start here. This is at 10, and we go all the way down to -2. So this length is 12. This is -2, and this is 3. So that length is 5. And we can actually do, this is the same problem as before on the previous slide, 12 squared, leg squared plus the other leg squared, equals the hypotenuse squared. And we just solved that, and we got that h was equal to 13. And actually maybe we should use distance, but our distance here between those 2 points is 13. So we can do this again. We have the point 6,4. So there's the point 6,4, -2, -11. I think -11 is actually off our graph a little bit. And we want to find that distance. So we want to find the distance from here to here. And what we can do is we can form another right triangle. And we can use Pythagorean theorem. So I'm going to work towards an idea here that I'm going to do on the next slide. But here, this is the point 6,4. And this is the point -2, -11. So these are still fairly close to each other, and we can count things off. So if we want to find this distance here, we go from -11 up to 4. And we could count that off and find that. But another way to do that is we're finding the distance or the difference between these 2 places. So we can actually just do 4, so our 4 value, and subtract the other y value. So 4 minus -11 is 15. And we'll see that this length is 15. We go 11 up to here and then another 4. So over here, we can do 6. Actually, we might think -2 minus 6. And which gives us -8, which is kind of interesting because this is a distance. So distances aren't negative. So how can we make a negative number be the positive or the opposite? Well, we can take the absolute value of it. So this length is 8. So we could count it off, or we can subtract the 2 values. So to find this horizontal distance, we subtracted, we did we did -2 minus 6, and to find the vertical distance, we did 4 minus -11. So we can subtract. And now that we have those distances, we can do 15 squared plus 8 squared equals the distance squared. So that's 225 plus 64 equals the distance squared. Add those together, you get 289. And if you use your calculator to take the square root of 289, you get 17. So that distance there is 17. Now in these examples, we've got integers for our answers, 13 and 17. It won't always work out that way. You could get a decimal. So find the distance between the point x sub 1, y sub 1 and x sub 2, y sub 2. And so I'm going to use that same idea that I just talked about in the last one, where we can draw this triangle. And we want to find the vertical distance. Well, to find the vertical distance, what we can do is we can take the y value minus the other y value. And in this case, it would be a positive number, but just in case, we can put absolute value there. To find this distance, we can do the x value. So it looks like a negative number here, but x value minus the other x value. And again, that might be a negative, so we're going to take the absolute value. And so these are our two distances. So this is the distance. This is one of the lengths of our legs, and this is the other length. And we want to find the distance d. And so we can do, I'm going to put the x's first because that's kind of what's normal. When we see this, also what I should have mentioned, and maybe I'll do it now, we actually could usually put the 1 first and then the 2. So we could say y sub 1 minus y sub 2 and x sub 1 minus x sub 2. Now, the nice thing is it doesn't matter the order that you put that in. All right, so we want this distance. So this is one leg, so we have x sub 1 minus x sub 2, the absolute value of that squared, plus the absolute value of y sub 1 minus y sub 2 squared is equal to the distance squared. So remember, this is a leg squared, so Pythagorean theorem, plus the other leg squared equals the hypotenuse squared. So that's what we're using. Now, when we square something, so this absolute value makes it positive, but when we square a positive number, we get a positive, and also when we square a negative number, we get a positive. So once we start using the Pythagorean theorem and square these things, we actually don't need the absolute value anymore. So we just can use parentheses x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared equals the distance squared. But we don't want the distance squared, we actually want the distance, so we would take the square root of both sides. And we get, and I'm going to just switch the order here, I'm going to put the d on the left side. D equals the square root of this part right here, x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. And that is the distance formula. So that could go right there in that spot. That is the distance formula. Know it. So find the distance between 3, 4, and 2, -1. Well, we could draw it out on a graph, put the points, draw the line, do the Pythagorean theorem, or we can just use the distance formula. So d equals the square root of x sub 1 minus x sub 2 squared, so 3 minus 2 squared, plus, so we're just using this formula, 4 minus -1 squared. And we get the square root, 3 minus 2 is 1, so 1 squared plus 4 minus -1 is 5, so plus 5 squared. So we got the square root of 1 plus 25. 1 plus 25 is 26, so the square root of 26 is the distance between these 2 points. It's going to be approximately equal to, if you put it in a calculator, 5.1. So that's the distance formula for 2 points, the distance between 2 points in a plane. Next, we have the midpoint formula. It's a little bit easier to understand. All we're actually doing is finding the average of the x's and the average of the y's, because you guys know how to find averages. You add the things together and divide by how many there are. When you're finding a midpoint, you're adding 2 x's together, so you divide by 2, and then add the 2 y's together. So let's use this. So the midpoint for this first one is simply going to be the average of the x's, so 3 plus -5 over 2. And the y value is going to be 8 plus 6 over 2. Which gives us 3 plus -5 is -2 over 2. 8 plus 6 is 14 over 2, and we simplify that. And the midpoint will be -1, 7. Same idea over here. So the midpoint, abbreviate that there, so 2 plus 5 over 2, that's our x value plus our other x value. And then the other point, or the y value, would be -1 plus 6 over 2. And we simplify. This is 7 over 2. So we got 7 halves, or 3.5, and this is 5 over 2. And so that's the midpoint. We can leave it as an improper fraction, or you can write it as a mixed number if you want.